Hi guys, I'm Riaz Mahmood Khan, your lecturer for the basic mechanical engineering subject. I think we have gone through the introduction, and I think we have gone through a couple of lectures while our university was open. But owing to the corona condition in the year, we have to go for online lectures. But but we have to go a little bit quick as we have little bit quick because I think for the first of the lectures for the forces of vector I have taught you in a couple of lectures, and I'll just repeat this lecture just to refresh your mind. And on this lecture, we will follow the book introduction by statistics and dynamics by R.C. Hibla. It's the 14th edition. The main topic in this, first of all, we are going for the chapter number 2. The main topic on this is the forces, vector forces, the scalar and vectors one. And this one, we know the definition. The scalar is a positive or a negative physical quantity that is specified by only by the magnitude, whereas the vector is is the directional quantity along with the magnitude. And we will go for a vector addition, vector operations. There is a couple of vector operations: multiplication or division of vectors by a scalar quantity, and similarly addition and subtraction of the vector. If the vectors are in the same, if the vector in the same direction, then we have to add them, and if they are in a total opposite direction, then we have to subtract them. A vector addition are followed by the two different laws: the parallelogram laws and the head and tail rule. Parallelogram laws, just like in this figure, we can just in this slide, you can see that there are two vectors a and b. They are if we extend these vectors, they are joining at some point, and then we will make a parallelogram of those two vectors, and the diagonal of the parallelogram will be the resultant of the two vectors. Do you know why we need the resultant of two vectors? Basically, in our daily life or in our engineering applications, we just have to face a couple of different forces, as is shown in this figure. A couple of different forces. We want to know the resultant of these forces. That what will be the resultant, and what will be the resultant of two forces if the forces are at different angles or in the same different directions or in the same direction. We are concerned with the resultant of those forces. How can we find the resultant of the forces? By addition of the vectors. Now, for the addition of vectors, there are two. We have to follow the parallelogram law and the head and tail rule. Head and tail rule says that the tail of the first is the head of the first will join with the tail of the head of the first will join with the tail of the second, and the head of the second will join with the tail of the third. And while the resultant vector will be the tail of the first vector with the tail of the resultant, and head of the last vector with the head of the resultant. And we can find it can be found by the trigonometric way or by resolving into different components, as we have already studied in our lectures. And we will just jump on to these. You have to go through all these slides, and now we will just jump on to the examples here, so that you can get more familiar how we have to find the resultant of the vectors. In this example, a screw eye in figure screw eye is pulled by two different forces, and the angle of the forces are given with the x-axis and the y-axis. And we will first of all draw a free body diagram just in figure B, and we will try to apply the law of cosine to determine the resultant vector. And for the magnitude of the vector, we will apply the law of sine. As it's already solved over here, you can just go through this one, and you will have a more better idea how to resolve these vectors, how to find the components of the vector, and how to resolve how to determine the direction of the resultant vector. Now, similarly, in figure example 2.2, it's just like the similar one, and it asks to determine the components of the vector along u and y, u and v, and the force for 600 pound is given, and you have as in the class we used to find the x and y component. Here we will just resolve that vector in u and v component. And here just think this vector is a resultant of u and v component of those forces. And then you will, as it's solved, you will apply the law of sine and you will get the f of u and f of v, which is required in this example. And this is example number 2.3. It's also just like the similar one, and you have to find the you have to find the fr. You have to find the f and fr for this one, and all the angles are given. You will apply the parallelogram law, and here by using this law of sine, you will get the both of the results. And similarly, it's example number 2.4. It is required the resultant force acting on the I bolt is directed along the positive y-axis, and F2 is have a minimum magnitude. Determine the magnitude of the angle theta and the corresponding resultant force. As you can see, it's already solved over here. It's a little bit tricky, but if you draw a free body diagram, it will be more clear to you what is required from you, what angle is required from you, and what's the force is required from you. Then you will get the more resultant area. It's already solved over here. Just try to solve it by yourself. And then in the end, these are a couple of different questions of the chapter. Try to solve it by yourself. Pick question number 1, 2, 3, 4, 5, 6. And then there were the very basic question. Then there is some a little bit more tricky questions are from 2.1 to 2. It's up to 2.30. Try to solve it by yourself, and for every try to solve it by yourself. I think we have a couple of questions we have solved in the class as well. But I'll recommend you try to solve all these questions by yourself. If you find any difficulty, we will discuss it in our discussion session. That's all for this topic. I wish you best of luck. This topic is very clear, and you will not feel any difficulty while doing these examples. And thank you, and see you next lecture. I wish you best of luck. Stay safe and be calm.